Now let's take a look at the point-slope form of the equation of a line. The point-slope form of the equation of a line with slope m that passes through the point x1, y1 is y minus y1 equals m times the quantity x minus x1. In this form, the input variable is assumed to be x and the output variable is assumed to be y. Just like in the previous form, if you change the name of the variables, you'll need to make the appropriate changes in the slope-intercept form. So let's go ahead and use this. Write the equation of a line passing through the point 2, minus 4 with a slope of minus 3. Using that information, we know that the point x1, y1 is 2, minus 4 and that m is equal to 3. Let's substitute these values into the point-slope form. We know what the point-slope form is from the previous box. If we substitute in the values, I get y minus negative 4 equals 3 times the quantity x minus 2. Simplify the left-hand side, that gives me y plus 4. And if I distribute the 3 onto the x minus 2, I get y plus 4 equals 3x minus 6. If I solve that for y, I'll find that y equals 3x minus 10. I did this by subtracting 4 from both sides. In some problems, you may notice that there are several correct point-slope forms because sometimes you're given multiple points. But when you put them in slope-intercept form, they'll all come out to be exactly the same thing. We could find that exact same linear form if we had started from the slope-intercept form. So let's start with that same information, the point 2, minus 4, and m equals 3. If we use the slope in the slope-intercept form, that yields y equals 3x plus b. To finish the problem, we need to find the value of b by substituting the point 2, minus 4 for x and y. So when we put that in, we get minus 4 equals 3 times 2 plus b. And when we multiply out the 3 times 2, we get minus 4 equals 6 plus b. If we subtract 6 from both sides, that gives us that b is equal to negative 10. So the equation for the line is y equals 3x minus 10. That's the exact same equation that we got up when we started from the point-slope form. Let's write the equation of a horizontal line passing through the point 2, minus 4. So a horizontal line has a slope equal to 0. So if we substitute this information into the point-slope form along with the point, we get y minus 4 equals 0 times the quantity x minus 2. If we go ahead and simplify, everything on the right-hand side will become 0. And if we subtract 4 from both sides, we get y equals negative 4. This makes sense because every point on a horizontal line through 2, minus 4 is going to have a y-coordinate of negative 4. If you just draw it, you'll be able to see that. Now, what would be the equation of a vertical line passing through 2, minus 4? A vertical line has undefined slope, so you can't use the point-slope form of a line. Instead, rely upon the observation we made in the previous example. Let's go ahead and draw that vertical line through the point 1, minus 2. Every point on this line has an x-coordinate of 1, so the equation of this line must be x equals 1. Let's go ahead and try a point-slope form on an applied problem. The percent of high school seniors who smoke cigarettes can be modeled by the linear function p equals f of t, where t is the number of years since 1975. In 1981, 32.7% of seniors smoked. In 2001, 32.1% of seniors smoked. Write the equation of this function. To get started, we have to realize what the appropriate point-slope form is. So in this case, we're going to use p for a percentage, and that's the same as the y, and t is going to represent time, and that's going to correspond to our years. we're going to let t be the years since 1975 as indicated. And now we have 2 points. T1 and P1 are 6, 32.7, and T2, P2 is the point 26, 32.1. We'll need to calculate the slope and then put the appropriate values into the point slope form. So to calculate the slope, we'll have P2 minus P1, T2 minus T1, instead of the usual y's and x's. So we get 32.1 minus 32.7 divided by the quantity 26 minus 6. If we work out the algebra on that, that gives us negative 0.03. So now we'll go to that appropriate point slope form, and if we put in the slope along with one of those points, doesn't matter which one, we just pick one, we get P minus 32.7 equal minus 0.03 times the quantity T minus 6. I'm going to distribute that negative 0.03 onto the T minus 6. I get P minus 32.7 equals negative 0.03T plus 0.18. And now if I add 32.7 to both sides, I get the P by itself, and I get P equals negative 0.03T plus 32.88. In summary, we've seen a number of different things here. There are some special cases of lines that we commonly encounter. The first one being the constant function, which is just a horizontal line, and that's just y equals some constant. I'm calling it b here. If we have the identity function, that's a function whose graph is a diagonal line, and that just means it goes through the origin, so the intercept's 0, and its slope is 1, and that's just the line y equals x. Vertical lines, as we saw, are just x equals some constant. The slope-intercept form with slope m and y-intercept b is y equals mx plus b, and the point slope form with slope m through the point x1, y1 is y minus y1 equals m times the quantity x minus x1.